Welcome to the Power Electronics class. Myself B. Veernarayana, Senior Assistant Professor, Department of Electrical and Electronics Engineering. We are in first unit, Power Semiconductor Devices. Up to now, we complete the characteristics of MOSFET, theory of operation of SCR, static characteristics, dynamic characteristics of the SCR, two transistor analogy, and the turn-on methods of the SCR. Coming to this module, here we are going to discuss about turn-off methods of the SCR and snubber circuit of the SCR. At the end of this lecture, the student will be able to explain the turn-off methods of SCR and protection of the SCR. What are the different turn-off methods of the SCR and protection of the SCR? So coming to the SCR turn-off methods, we discuss different turn-on methods of the SCR. Turn-on methods of the SCRs are used to brought the SCR from forward blocking state to forward conducting state. We have different turn-on methods: forward voltage triggering, temperature or thermal triggering, dV by dt triggering, light or radiation triggering, and gate triggering. Out of this, the gate triggering method is most economical, efficient, and advantage one. So, whenever the SCR is in forward blocking mode, if you provide the voltage across gate and cathode terminals, then the SCR comes to the on state. Once the current flow through the SCR crossovers the latching current, then the gate loses its control and the conduction of SCR. That means the gating voltage is used to turn on the SCR, and if you remove the gate voltage, once the current flow through the SCR greater than the latching current, it does not shows any effect on the conduction of SCR. That is, continuously the SCR will be in the on state. So, how you brought the SCR to the off state? So, here the SCR can be turned on by applying appropriate positive gate voltage between the gate and cathode, but it cannot be turned off through the gate terminal. So, how the SCR should be bring back to the forward blocking state from the forward conducting state? Simply by reducing the current flow through the SCR below the holding current or 0, then we will say the SCR will be in the off state. So, the turn off process of the SCR is simply called commutation. The turn off mechanism of SCR or the turn off process of the SCR is called commutation. And here the commutation means simply the turn off process of SCR, and the term commutation means the transfer of current from one path to the another. So, the commutation circuit does this job by reducing the forward current to 0 or below the holding current to turn off the SCR. So, here to turn off the conducting SCR, you must fulfill the two conditions. We will say if these two conditions should be fulfilled by the SCR, then we will say the SCR will be in the off state. Those are the anode or forward current must be reduced to 0 or below the holding current. First one, the current flow through the SCR is 0 or below the holding current. And second one, a sufficient reverse voltage must be applied across the SCR to regain its blocking capability. To regain the blocking capability, if you provide the sufficient negative voltage, then we will say the SCR is continuously in the off state. Even though the first condition was satisfied, if the second condition is not satisfied, then the commutation failure may be taken place. That means, see, when the SCR is turned off by reducing the forward current to 0, even though the current flow through the SCR is 0, there exist charge carriers in different layers. So to regain the forward blocking state of an SCR, these excess carriers must be recombined. Therefore, the recombination process is accelerated by applying a reverse voltage across the SCR. If you don't provide the reverse voltage across the SCR, then there is the free movement of the excess charge carriers present in all the junctions. There may be a chance of the commutation failure will be taken place, and again the SCR is continuously in the on state. So you must ensure that if you want to set the SCR is continuously in the off state, we will fulfill the two conditions. The first one is the current flow through the SCR is below the holding current or 0, and second one is a sufficient negative voltage is available across the SCR, then the SCR is comes to the off state. So here the reverse voltage which causes to commutate the SCR is called commutation voltage, and depending on the commutation voltage located, the commutation methods are mainly classified into two types. Depends on the commutating voltage located, the commutation process or commutation methods are mainly classified into two types. Those are forced commutation and second one natural commutation. Those are forced commutation and natural commutation. So here where we use the natural commutation and where we use the forced commutation means, if the circuit is energized by the AC supply, then we use the natural commutation. Here this natural commutation is used whenever the circuits are energized by the AC supply, like in phase controlled rectifiers, AC voltage controllers, cycloconverters. There the circuits are energized by the AC supply. For that applications we use the natural commutation. And second one, forced commutation. This forced commutation is used when the circuit is energized by the DC supply. Circuit is energized by the DC supply means like choppers, which are called DC to DC converters, and inverters like DC to AC circuits, where the circuit is energized by the DC supply. Then we go through the forced commutation technique. First we go through this natural commutation method. Later we discuss the forced commutation methods. So this natural commutation is also called line commutation or class F commutation. So here the natural commutation is also called line commutation or class F commutation. So this natural commutation is preferred if the circuit is energized by the AC supply. And in natural commutation, the source of commutation voltage is the supply source itself. The nature of the source of the commutation voltage is supply source itself. That means there is no requirement of the additional components to commutate the SCR. Commutate means turn off process of the SCR. So if you go through the forced commutation, you require some additional components which are forcibly reduce the current flow through the SCR below the holding current. If you go through the forced commutation, there is some external circuit or external components must be required which are used to forcibly reduce the current flow through the SCR below the holding current. But in case of this natural commutation, there is no requirement of the additional components. So the source itself will provide the commutation voltage, and corresponding that the SCR may goes to the off state. So here we will go through the simple example. Here we have the AC source as the input, which have the magnitude Vs is equals to Vm sin omega t, and I just want to transmit this AC voltage to this load by using this SCR. Here the SCR terminals are anode, this one is cathode, and this is the gate. So I just want to transmit this AC source to the load. I just want to convert the AC to DC simply by using this rectifier, simply by using the single SCR. So this circuit is simply called single phase half wave rectifier. Single phase half wave rectifier. And coming to this operation, here we provide the AC voltage as the input. This is the pi and this is the 2 pi. So during the positive half cycle of the supply, what happens? This anode is made positive and this cathode is negative. So during this positive half cycle, when anode is made positive and cathode is negative, what happens? The SCR will be in the forward blocking mode or forward biasing mode. So from 0 to pi, during the positive half cycle of the supply, the SCR is continuously in the forward blocking state. At omega t is equal to 0, we provide the gate current. So we providing the gate current. That means we provide the gate voltage across this gate and cathode terminals. Corresponding that the gate current should be flows. So if you provide the gate current, then the SCR comes to the on state. At which instant we provide the gate current? At t is equals to 0. So from this instant, from time t is equal to 0 to pi, that SCR will be in the on state. SCR will be in the on state means the switch will be closed and the current flow through the circuit is like this. If the current flow through the circuit means, if you have the load is taken as purely resistive, then the output, and if you go through this voltage from 0 to pi, thyristor or SCR will be in the on state. If SCR in the on state, this total source voltage is available across the load. Then the output voltage will be like this. And here we have the resistive load now. So output current is simply in phase to the voltage. And this magnitude is given by V naught by R. The magnitude of the load current should depends upon the load resistance. Hence why IL is equals to V naught by R. Here we have the resistive load. The output current is simply in phase with respect to the voltage. So up to 0 to pi, the output voltage will be present like this. The total positive half cycle is transmitted from source to the load through the SCR. Assume ideal SCR. Ideal SCR means there is no voltage across the SCR. The total source voltage is transmitted to the load. And output current is in phase to the voltage like this. And at omega t is equal to pi, the output voltage is 0 and output current is 0. Output voltage is 0 and output current is 0. After pi, from this pi to 2 pi, the negative half cycle will be available across the SCR. During this negative half cycle, the anode is made negative and cathode is positive. The anode is made negative and cathode is positive. Corresponding that, the SCR is automatically comes to the reverse biasing mode. At omega t is equal to pi, the current is 0 and after this the negative voltage is available. Due to that negative voltage, what is the state of SCR? When anode is made negative and cathode is positive, that SCR is in reverse biasing mode. Reverse biasing mode is nothing but off state of the SCR. So if the SCR is in off state, there is no voltage from pi to 2 pi and there is no current from pi to 2 pi. This total source voltage is simply, here if you draw the voltage across the thyristor waveform, from 0 to pi, it is in the on state, hence why there is no voltage. But from pi to 2 pi, the SCR will be in the off state, then that negative portion of the source voltage is available across the thyristor or SCR. or SCR. So when the SCR is in the reverse biasing mode, this total source voltage is available across the thyristor and corresponding the output voltage and output currents are 0. So here at pi current is 0 and the negative voltage is available across the SCR. So we will fulfill these two conditions. First one is current flow through the SCR is 0 and second one is negative voltage is provided across the SCR to remove the charge carriers present in the outer 4 junctions. So if you fulfill these two conditions, then the SCR may goes to the off state. That type of commutation is called source commutation or line commutation or class F commutation. So this commutation is possible with the line commutated inverters or controlled rectifiers or cycloconverters and AC voltage regulators, because that converters are energized by the AC source. That converters are energized by the AC source. During the negative half cycle of the supply, if the SCR is going to the off state, then that type of commutation technique is called the natural commutation or class F commutation or line commutation. So in this commutation technique, we did not use any external circuits. Simply depends on the nature of the source. The SCR may goes to the off state. For every completion of the positive half cycle, after this line crossovers the positive half cycle, the negative half cycle will be present across the SCR. During that negative half cycle, the SCR is automatically goes to the reverse biasing state, and which may cause to the off state of the SCR. If SCR should be turned off, depends upon the source voltage. The type of commutation is called class F commutation or natural commutation or source commutation or line commutation. And next one is the forced commutation. Forced commutation means, for example, here we have the SCR and this SCR should be energized by the DC source. Here it is anode, here it is cathode, positive terminal, negative terminal. Here I am taking the resistive load, for example, and we provide the voltage across gate and cathode terminals, gating voltage. So when anode is made positive with respect to the cathode, what happens? That SCR comes to the forward biasing mode. No problem. If the SCR is in forward biasing mode and we provide the gate voltage across gate and cathode terminals, what happens if you provide the forward break? If the SCR is in forward biasing mode or forward blocking mode and we provide the gate voltage, then what happens here? The SCR comes to the forward conduction state or on state. Forward conduction state or on state. If the SCR is in the on state and you ensure that the current flow through the SCR is greater than or equal to the latching current, then what happens? Even though you remove the gate voltage, after the current flow through the SCR crossovers the latching current, then the SCR is continuously in the on state. Continuously in the on state means the gate loses its control and the conduction of the SCR. And the conduction of the SCR. So how you turn off the SCR? So if you want to turn off the SCR, you make to ensure that the current flow through the SCR is either equal to the holding current or less than the holding current, and some negative voltage will be available across the SCR. Then we will say the SCR will be in the off state. So to fulfill these two conditions, to turn off the SCR, we depends on the external circuit. So we already said the commutating voltage which is used to brought the SCR into the off state. Then in this forced commutation, that we use some external circuits and we will forcibly reduce the current flow through the SCR is below the holding current at 0 and some negative voltage will be available across the SCR. So that circuits are called forced commutation circuit. And here, see here, in case of DC circuits, there is no natural current 0 to turn off the SCR. So, in such circuits, the forward current must be forced to 0 with an external circuit to commutate the SCR. Hence, it named as forced commutation. Hence, it named as forced commutation. So, here, this commutating circuit consists of components like inductor and the capacitors, which are called commutating elements. So, to commutate this SCR, which depends on the commutation circuit, and that commutation circuit is designed by the external inductors and the capacitors. So, those are simply called the commutating elements. So, based on the manner in which the zero current achieved and the arrangement of these commutating elements, the forced commutation circuits are mainly classified into 5 types. Depends on the circuit configuration or circuit arrangement and the way how you reduce the current flow through the SCR below the holding current is 0. The forced commutation circuits are mainly classified into 5 types. Those are class A or self or load commutation. Second one, class B or resonant pulse commutation. Third one, class C or complementary commutation. Fourth one, class D or auxiliary commutation. And fifth one, class E or external pulse commutation. Class A or self or load commutation, class B or resonant pulse commutation, class C or complementary commutation, class D or auxiliary commutation, class E or external pulse commutation. These are the different forced commutation circuits, and these commutation circuits are used whenever the circuits are energized by the DC source like choppers and the inverter circuits. So, these commutation circuits are mainly used in choppers and the inverters where the circuits are energized by the DC supply.